Alright, so in this video, we're going to talk about measurements of angles. Now, it's important to note some few things. First thing to note is that positive angles are measured in an anti-clockwise direction. So positive angles are measured in an anti-clockwise direction. So we have something like this and this, and if you go this way, this is an anti-clockwise direction. So this is a positive angle. Second thing to note is that negative angles are measured in a clockwise direction. So if you have something like this, and you're measuring, moving this way, this is a negative angle. So that basically, for the course of this video, they're basically just two things we're going to discuss that helps us quantify angles. So the first thing is degree, and the second is radian. So we'll start from degree. Now, a degree it's not a unit per se, but we use it to quantify angles. So let's talk about degree. Now, first thing to note in degree is that the decimal parts of an angle in degree can be converted to time. So let's say you have an angle, let's say 120.32 degrees. The decimal parts of this angle in degree can be converted to time, most especially minutes. So we're going to take some examples to understand this little concept. So let's take example A. Okay, it's important to note that 60 minutes, denoted with this symbol 60 prime, gives you 1 degree. This is 1 degree. So it's important to note that 60 minutes gives 1 degree. So let's take a few examples. Example A. We're asked to convert this to degree and minutes. So they say convert the following to degree and minutes. 120.32 degree. So the first thing you want to do is to break this down into two parts, the normal part and the decimal part. So this can be written as 120 degrees plus 0.32 degrees. So just take everything before the decimal point as 0.32. So as we said, the decimal part of this angle, just this part, can be converted to time. So we use the normal standard. We said 1 degree gives you 60 minutes. That means 0.32 degree will give you x minutes. So we cross multiply and we'll figure out that x times 1 degree gives you 0.32 degree times 60 minutes. Divide both sides by 1 degree. You can see that x gives you 0.32 because this is going to cancel out. So 0.32 times 60 minutes. And finally, your x gives you 19.20 minutes. Now you're going to approximate this to the nearest minutes. So this is what you're going to get. So approximating this to the nearest minute, x gives you 19 minutes. So your final answer is going to be written this way: 120.32 degree gives you 120 degrees 19 minutes. 120 degrees is coming from this point here. This point, 120 degrees, then 19 minutes. This is exactly how you denote your answer. So let's take another example. We have example 2. Example B, 16.24 degrees. So you can quickly pause the video and attempt something. So we have 16 degrees plus 0.24 degrees. Now remember, we said just this part. So if 1 degree gives you 60 minutes, that means 0.24 degrees will give you x minutes. So you cross multiply. X gives you 0.24 degrees times 60 minutes all over 1 degree. This is going to cancel this. So x gives you 0.24 times 60, which gives you 14.4 minutes. Approximately 14 minutes to the nearest degree. So your final answer is going to be written this way: 16.24 degrees gives you 16 degrees 14 minutes. 16 degrees is coming from this point. So this is basically just what you need to know about converting the decimal parts of an angle to time. You can also break it down to seconds if the question requires you to break it down. Then let's look at some examples where we have to convert from degree and minutes back to degree. So let's check some examples. So let's check question number 1. If you're meant to convert, let's say 14.4, not 14.4. We're going to convert 14 degrees 4 minutes to degree only. What are you going to do? Now you're going to reverse the process. You're going to break this down. So remember, you're just converting just this. So you're going to have, if 60 minutes gives you 1 degree, 4 minutes will give you what? X. Cross multiply. X gives you 4 minutes times 1 degree all over 60 minutes. Minutes will cancel out. So you're left with 4 over 60 degrees. This gives you 0.0667 degree. So this time around here, unlike the previous example when we're converting from degree to degree and minutes, this time around you don't need to approximate. So once you get to this point, this is what you're going to do: 14 degree plus whatever you get here, 0.0667 degree. This gives you 14.0667 degree. So this is your answer. It's kind of like varies with the method for this one. So just note the difference. For this one here, the first thing you have to do is to break it down to this form. But for this one, you don't need to break it down. Just take only this to solve. For this one, when you get your final answer, you have to approximate to the nearest minute. For this, you don't need to approximate to the nearest minute. Then when you get to this, you just write this out. But for this, you have to add. So this is just like the reverse of this. So let's take another example. I think there's a fourth question on this. So question number 4, they said convert this angle -143 degree 10 minutes to degree only. So this negative sign just indicates that the angle moves in a clockwise direction, as we said earlier. Moves in a clockwise direction, so there's nothing to be scared of. Just solve with the symbol there. So this is like the second kind of solving, because we have to convert minutes to degree. So we just move with this alone. So if 60 minutes gives you 1 degree 10 minutes will give you how many degrees? So cross multiply. X gives you 10 minutes times 1 degree all over 60 minutes. This will cancel out. So you're left with 10 over 60, which gives you 1 over 6. And in decimal form, X gives you 0. X gives you 0.16666, so approximately 167 degrees. So when you get to this point, there's no need to approximate to the nearest degree. Just add it to whatever you have here. So you're going to have minus 143 degrees plus 0.167 degrees. So this is going to give you negative 143.167 degrees. So this is basically just what you need to know about conversion. Now we go over to angles in terms of radian, where we talk about the conversion rate and other things. So the first thing to note, here is we're talking about radian now. The first thing to note is that 1 radian is equal to 180 degrees over pi. Yes, pi, as in, yeah, you know the value of pi. This gives you 57.2958 degrees. So this is a standard. If you convert this to degree and minutes, you're going to get 57.18 minutes. So this is a standard for radian. 1 radian is equal to this. I'm quickly going to give you like the conversion rates for. So when you want to convert, so conversion between radian and degree. So when you want to convert from degree to radian, you simply multiply by pi over 180. But when you want to convert from radian to degree, you simply multiply by 180 over pi. So as usual, we're going to take some examples to tackle this. So let's take the first question. The first example says, example 1. Says convert the following from radian to degree. So the first angle is 3.2 radian, or short form of writing radian is rad. So 3.2 rad. You're meant to convert this to degree. So what do? You multiply, as we said, you simply just multiply by 180 over pi. So this is going to be 3.2 multiplied by 180 over pi. This gives you 576 over pi. Now you can actually leave your answer this way with pi in it, rad, or you express it in decimal. So you're going to have 183.346 rad. Now we'll check question number 2. We have negative 1.58 radian or rad. So you do the same thing, just multiply with the symbol there times 180 over pi. This gives you negative 90.527. Sorry, this is an error here. Forgot we're converting from radian to degree, so this is meant to be in degrees. This is meant to be also in degrees. So this is basically how you convert from radian to degree. Let's say we have something like this. Let's say we have 2 pi rad. I'm going to convert this. So you have 2 times pi. 2 pi multiplying 180 over pi. So pi is going to cancel this out. 2 times 180 gives you 360 degrees. So it's also a standard that 2 pi gives you 360 degrees. 2 pi rad. 2 pi rad gives you 360 degrees. This is something I'd like you to note. Okay. So let's take some examples where we have to convert from 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 degree to radian. So take example 1. Okay, so take example 1. Let's say we have to convert 225 degrees to radian. So this is very, very straightforward. You just go this way. 235 multiplied by pi over 180. This gives us 47 pi over 36 radian. You can leave your answer this way, or you can convert to decimal, which is going to give you 4.102 rad. So let's take another example. We have 57 degrees 18 minutes. Now this kind of example, you have to apply what we learned earlier on. You have to first of all convert 18 minutes to degrees. So if 60 degrees gives us, if 60 minutes gives us 1 degree, 18 minutes will give us x. So we cross multiply. We're going to have x to be 18 over 60, which gives us 0.3 degrees. So simply this is going to now be 57 degrees plus 0.3 degrees. This gives us 57.3 degrees. So this is the first step. Now the second step is now to multiply. So we have 57.3 multiplied by pi over 180. So when you do the multiplication, you're actually going to get 1 radian, approximately 1 radian. So this means that 1 radian is equal to 57.18 degrees. I think we stated that yes. So we stated that 57.18 degree is equal to 1 radian. So this just confirms what we actually stated earlier on. So this is okay, that some things you need to note again. You need to note that one more thing to note. You need to note that 1 revolution is equal to 360 degrees. Is equal to 360 degrees and is equal to 2 pi rad. So this is like a standard for revolutions and degrees and radian. So yeah.